Hi everyone, so today I'm going to present you a valve package of an AHU I've been working on that project. So the AHU is right behind me, so I hope you're gonna like it. See you right after. So first let's have a quick look on the AHU. So this is a dual flow AHU unit with two coils, one hot water coil and one chill water coil. First thing, let's speak about the shut-off valve. So here you have the shut-off valve, so it's very important to always put shut-off valve before any other hydraulic components such as the strainers or the control valve. So if you need to do anything such as like cleaning the strainer, you won't have to drain the whole water system. You would just have to shut off this valve and then drain only these coils using the drain right here. Right here. The second component you will have to install is the strainer. So here you have the strainer for the hot water coil, and here you have the strainer for it's insulated so you don't see it well, but this is the strainer for the chill water loop. With the strainer you will make sure that your water system remains clean all the time, like all the impurities will be captured by this strainer using a small filter, and so all the impurities will remain in this small location. And what's very important to do is always to monitor the pressure drop you have in your strainer, because what's gonna happen is like as the impurities flow in the strainer, they will build up in the strainer, and the pressure drop through the strainer will increase a lot. If the pressure drop is too high, the strainer won't be efficient anymore. So what you need to do is to install pressure gauge, like here you have one. This pressure gauge has to be able to monitor the pressure drop through the strainer. So if you want to measure the pressure upstream of the strainer, you just open this valve and you close this one. So you will be able to measure the pressure here. Then you do the same, you close this one and you open this one, and you will be able to measure the pressure here. Then you check the pressure drop. If the pressure drop is too high, it means that you need to clean the strainer. So another very important component is of course the control valve. So here you have the control valve for the hot water coil, and here you can see the control valve for the chilled water system. Something very interesting to notice about this control valve is that it's not only control valve, it's also a balancing valve. So the huge asset by using this pressure independent control and balancing valve is that you only need to install one valve instead of having one control valve and one balancing valve. So here you just have one valve for both functions. And the other thing which is quite interesting with this valve is that it's pressure independent. It means that whatever the pressure you have in the system, it will always ensure that the flow is matching the design flow for that coil. And there is close to zero commissioning for this type of component, because you just need to set the flow to the right flow during the installation. So the maximum flow you can have in that valve is 1.7 square meter per hour, and the design flow for this one is 0.7. So you just need to set it to 41% of the maximum flow. And that's it. The installation is done. You won't have to do any balancing during the life of the building. And this is what's really interesting in that valve, because you don't need to manually balance each valve every time you are adding a new coil or a new terminal to your system. So then you have the energy meter that I like to put on my units in order to measure the consumption for a building purpose. The energy meter is always installed on the return. And you will have to install two temperature sensors, one on the supply and one on the return. The energy meter is going to calculate the delta between the supply and the return temperature, and it's also able to measure the flow. So when you have the delta T and the flow inside the pipe, you get the energy consumption of the hot water coil. And we have the same for the chilled water. So these energy meters are able to communicate to the BMS system. So don't forget to ask for the communication card. So here for this system is LoanWork. So we had to ask for a LoanWorks communication card to install. And here you have the wire going to the BMS system. Then don't forget to install industrial thermometer. So these are 90 degrees angle industrial thermometers because you have this angle 90 degrees here. So this one is a 150 millimeter case and 63 steam, which is the length of the small part which is going inside the flow to measure the temperature. And so we have the same on the chill water side. So the temperature range for this thermometer on the hot water coil is 0 to 120 degrees Celsius. And for the chill water side, the range is -30 to 50 degrees Celsius.